Okay. Hello, class, and welcome to discussion this week. This week, you guys talked about different sorting algorithms, merge sort and quicksort to be exact. But today, I'll be giving you an example of what quicksort looks like because I heard you guys had a hard time understanding what it looks like. So I'm just giving you an animation without the code involved, just to show the idea. Then we'll talk about the code at the end. All right. So. Here, I have an array of integers. We have 2, 9, 11, 1, 7, 8, just in case you can't see. But as you see, they're unsorted. What quicksort does, what it does is it chooses a pivot being a random number in this array, then partitions the left side of, partitions the left side of the array, or partitions the array where the left side of the pivot has values greater or values less than the pivot, and the right side of the pivot has values greater than the pivot. And then from there, it recursively calls itself until it is sorted. Quicksort is a really good algorithm because it has average case of O of n log n, which is really good, just like merge sort. So let's just do an example here. So as you can see, I have, the way I like to do quicksort is I used 3, maybe 2, you can do it in 2 or 3, but I use 3 different pointers. I have a less than pointer, a greater than pointer, and a pivot pointer. So what this will do is you pick the pivot randomly. Here I just chose 7 just because. So my pivot here is 7. After choosing a pivot, what I like to do is swap the what's pointed at greater than. Greater than will always start off at the end of the array, and less than will always start off at the left side of the array, at the beginning of the array. So I swap what's in the pivot with what's at greater than. So we then have, that marker doesn't work. So then if we draw our new array, we have an array, and it looks like 1, 2, 3, 4, 5. So it now looks like this: 2, 9, 1, 1, or 11, 7, not 7, 8, and 7. All right, so now this is the pivot, and the greater than pointer will now point 1 minus the end of the array. So greater than is now here, and less than is here, still there. So what we will do now is we're going to move greater than down. We're going to move greater than towards the beginning. We're going to move less than towards the end. We will stop greater than when the pointer at greater than gets on a value that is less than the pivot, and we will stop the less than when the value that less than is pointing to is greater than the pivot. When both have been stopped, we swap. We swap greater than and less than. We will stop this operation after greater than is less than pointer. So here we go. So we look at greater than. We say greater than is pointing to 8. 8 is in our pivot is 7. That means 8 is greater than 7. That we can move on to the next step, which is 1. So we greater than now points at 1. Greater than is 1. Which is less than 7, so we stop greater than. Let's move on to less than. Less than is 2. 2 is less than 7, so we can move on to the next one. Less than now is 9. 9 is greater than 7, so we have to stop less than. What we do here now is we swap greater than and less than. So now 1 will be here, and 9 will be here. So that holds. We can increment less than or greater than, doesn't matter which one. Less than is now 11, and less than is now 11, so it stops. Greater than increments to the same value that less than is, which is 11. 11 is greater than 7, so we can increment greater than again. Greater than now points to here. We stop our iteration after greater than is less than. After the greater than pointer is less than the less than pointer. So this stops now. What we want to do at the end is swap the value in less than with the value that pivot is pointing to. So now we swap. So this will now be 7 and this will become 11. As you can see, our pivot was 7. Everything to the left of 7, which is 1 and 2, is less than 7, and everything to the right of 7 is greater than 7, 9, 8, and 11. We will continue to do this until the. So after this, we recursively do this as we continue to pick random pivots and we set the values of the pivot left to be less than the pivot and the values of the pivot right to be greater than the pivot. This is done average time O of n, but if we were given a terribly, if a malicious person knew that we were doing quicksort and wanted to make our runtime O of n squared, they could do that. As worst case, quicksort is O of n squared. But quicksort is a really good algorithm, and it brings rise to quick select, which is a really cool algorithm that you can select things pretty fast. You can select the kth element pretty fast. If this animation doesn't help you, come to office hours today. I'll be there today. Thanks for coming, guys, and I'll see you guys later.